This is the best explanation I ever heard of a neural network.
People started using it and so on, and right now you can't do anything anymore without the internet. And that's the same with AI. If inside the system, in the deep learning model, it kind of switches, okay, the most optimal way to avoid that there are coming rockets to us is firing our rockets.
Welcome to Apple Finch Pudding, your gateway into the world of science. Today's scientist is Broes Laekeman, a PhD researcher in agricultural and food sciences at ILVO and UGent. Welcome, Broes.
Hey, good morning. Thanks for inviting me.
Thanks for being here. My first question is always the same. Do you have a fun science fact for our listeners?
Well, I knew that the question would be coming, but I didn't know anyone or any fact. But yesterday I was reading an article, and apparently thrips, so the insect with which I'm working, um, apparently they prefer virgin females compared to other females. So I had quite a laugh.
Yeah, that's a
Yeah,
bit
so
of a weird fact, but that's nice.
yeah. So the title is "Experienced Males Recognize and Avoid Mating with Non-Virgin Females in Western Flower Trips." So yeah, they're slippy bastards.
Yeah. Okay. So you work in agricultural and food sciences. I can imagine that most listeners are just imagining farmers on a field. That's not completely what you do. So could you explain the research field in general?
hmm so the whole research field, so agriculture and food sciences, are any science related to agriculture and food, you could say.
Makes
But
sense.
yeah, true. But not only, I mean, new harvesting techniques and so on, but could also be, for example, ILVO, the research institute on which I'm working. They also develop high-tech drones, which help at sowing the fields, but also alternative food processing methods, also breeding for climate resilient crops. So it's not only like very farmer related. I mean, it's related to agriculture and food, but it's like very, very broad. For example, my research, it's also part of it, but I'm focused on ornamental crops, so more flowers and nice looking plants, which only actually have the function of being beautiful and they don't need to produce food, for example. Um, so yeah, that's basically my research field, the ornamental plant sciences or floriculture.
All plants are nice, but I get your point because
Yeah.
some
There,
plants have a better aesthetic aspect or a greater aesthetic aspect than others.
yeah. So you have the electrician plant and the princess plant.
Okay, yeah, we can mention it like that. So, and you're working on the princess plants or something.
Yeah,
Yeah,
they
okay.
just need to look nice.
Okay, and then what is the goal? So you're working with the princess plants. What do you want to do with the princess plants?
So my PhD is part of a bigger project, which actually is looking if it would be possible for the Flemish breeders. So we're Belgian, both of us, and yeah, I don't know why I mentioned because of the Flemish breeders or growers, and currently they grow the flowers, the nice-looking flowers, inside greenhouses. But actually, greenhouses it works quite well, but it of course uses quite some energy to heat the whole greenhouse and so on. And also, space is quite limited here in Belgium. So that's why they are looking from the government if it would be possible to switch to ornamental vertical farming. So vertical farming instead of growing just plants next to each other, above each other, so stacking them vertically, because in that way you could use the space more efficiently. Of course, there can also be pests and diseases occurring inside the vertical farm. So I'm also scouting for that using the cameras, or at least trying to. And now we're also looking at can we treat pests and disease infections using light, so UVC light, RGB light, and some other parts.
Yeah, and I can imagine, like you said, that temperature, like if you have to heat a greenhouse, that's a major cost. So by applying vertical farming, you can actually reduce that cost because you have more plants in the same space. Is that one of the ideas that you try to tackle?
it's not actually a problem that I'm trying to tackle. That's a major advantage of vertical farm because it's also insulated and so on. But I'm trying to make some kind of a crop development model and look if it's possible to steer it using other climates. So you adjust the climate based on how the plant develops real time. So you know if you plan, for example, okay, my plant will be ready within 8 weeks normally. But if you're 6 week far and you see, okay, my plant is not uh, growing that well, my model would suggest some changes in climate early on to make sure that you get that harvest date.
And I think one of, or a few of the bigger differences compared to normal greenhouse farming is that, yeah, because of the vertical layers, the humidity will be different, but also the light, because you have to add more lights, right? And is that then part of the inputs that you're trying to control to have an ideal output?
Yeah. So the parameters which I'm focusing on right now is light intensity, which is very important for flower plants, of course, temperature, humidity, and CO2 concentrations.
One of the things that you focus on is also pest detection, but on what pests do you focus and why are they a problem?
Yeah. So my system will focus on thrips and whitefly. Thrips are actually very small insects, and the Flemish name of it is actually yeah, dondervliegje, which is like thunder fly, because when it's when you have a thunderstorm, just the minutes before or the hours before, you have like very small flies that are or insects that are everywhere, and apparently those are also trips. I didn't analyze. We don't have that many thunderstorms over here, so I didn't analyze or check the fact. But yeah, it's a very small insect. I think it's 1 millimeter big, so very, very small, very tiny. Um, and whitefly, it's 1 to 2 millimeters. It's actually a small fly with white wings. You can see them very well because they're white. Um, but yeah, they cause major damage actually to crops. If you have it in a greenhouse, for example, they spread very fast, so their reproduction cycle is very short. So they can produce, yeah, their amount can increase very rapidly and spread everywhere. They cause direct damage to the plant, so they eat parts of it, but also indirect because most of them can also transmit viruses, and you really don't want to have that in your plants as a grower. So yeah, that's why we focused on it because especially for ornamentals, like I said, they're princess plants, so every small dot on top of it, or every small blister, or I don't know what, really causes financial loss.
You mentioned they have a short life cycle, but what is short? Is it an hour or is it 10 days? 10 days is also relatively short,
Yeah,
but
they're
yeah.
not bacteria,
No, yeah.
but for example, trips depend. It also depends on climate conditions, temperature, humidity, and so on. But for trips, I think around 25 degrees and let's say 60% humidity, it's only 2 weeks to go from an egg to an adult. But every adult, once they're adult, I think the females lay a few hundred eggs per day, and they live 1.5 months or something like that.
Yeah, yeah. So if you see them, you have to act very fast because otherwise you have a big problem.
Yeah. That's why normally right now they use sticky plates or sticky traps. It's actually just a fluorescent plastic, piece of plastic, which they cover with very sticky glue.
Which you love, by the way. I
Yeah.
noticed.
It's fine.
Before we started, you said, there's some of that glue on my headset. I was like, okay.
Yeah, it's really a pain in the ass to get it off, but yeah, it works. It's like it's just a piece of plastic card covered with glue, and they get attracted by the fluorescent color of it. Most of the time, they're yellow because the color also depends on which species they attract. So you have different trip species, subspecies, and some of them are more attracted to yellow, some of them are more attracted to green, and so on. And that really depends on their. So they have light receptors inside their eyes. So for UV, blue, and green light, but it really also depends from population to population. Some of them are more like their sensors are more towards the green part or more towards the blue. So yeah, but yellow is quite commonly used because they attract everything. So they just they fly around, they think that it's a flower, they fly towards it, and then they get stick to it. And actually, they use that to monitor for trips. But they just put the sticky traps there, and then you have people walking around continuously in the greenhouse looking at those cards. Do we already have trips? No. Okay, that's fine. But once they see we have trips, they really try to act as fast as possible to get the plants out, to spray pesticides. But at the moment, that's not allowed anymore to use every product. Also, you have a lot of pesticide resistance. So yeah, and those traps also, of course, catch some trips. I mean, they're like covered in trips, but you won't get your greenhouse trips free just by using those sticky traps. It's really for monitoring.
Okay, so that's something I didn't know. Actually, two things I didn't know, because I didn't know they were attracted really to the color. So
Yep.
that's interesting to me. So, because yeah, I understand that they could be attracted to flowers since the same color, but it doesn't look like the shape of a flower most of the time. It's like a big square or something.
Yeah, yeah.
So and also it's like you said, it's used for monitoring, but not for actually removing the pests. So how do you remove the pest then?
Well, it's a combination. So if you put a lot of sticky traps, you can kind of reduce the trips
Mhm.
population, but you won't kill all of them. At least if not if there's a big population. But then yeah, it's a combination with spraying pesticides. They also have biological countermeasures, which are just like other trips which eat the bad trips or
They have a
other
problem
insects.
with with the new trips.
But yeah. For example, BioWest is a Belgian. I think it's originally a Belgian company, and they sell like beneficials they call them. It are other insects which eat the bad insects. For example, everybody knows aphids, but
Yeah,
is aphid like the common English name, or is it
I
like
think
the
so.
yeah? For
Yeah,
example, they use them. Oh yeah,
ladybugs.
what ladybugs? Yeah, thanks. And ladybugs aren't bad for your plants, but they eat the aphids, which is nice. So for trips, it's kind of the same. Yeah.
Yeah. Yeah, they
Uh,
also had yeah, that's also sometimes a problem because like they imported in the past like Asian ladybugs, but now
mhm.
those Asian ladybugs are a problem here because they outcompete the native ladybugs.
Yeah,
So
true.
yeah, so it's
Yeah,
good to have a pest control that is local if possible.
true. But I think BioBets is also looking for that because they can't just do whatever they want. They
Yeah,
also have
yeah.
strict legislation. By the way, I think I said that the trips think that the yellow plate is a flower, but they just think it's a plant because the yellow color triggers their green receptor.
Okay. Okay. One of the bigger parts of your research is actually the detection of these pests.
Hmm.
You use AI for that.
Hmm.
So can you tell us a little bit about that workflow, what you're doing exactly?
Yeah. So AI is a very broad term, first of all, because at the moment you hear it everywhere. Every company says, yeah, we're going to solve it with AI. And I kind of hate it when they tell it because, yeah, it's such a broad term. But yeah, what I'm doing, I'm using deep learning, which is a subfield of AI. And actually, I just feed images to a neural network. Probably everybody has heard of neural networks so far. I feed images to it, then train the neural network, and then the system actually learns how to recognize my pest. So I feed images, I feed the solution, so like the labeled image, so just an image with a rectangle, like rectangular shape around the pest, and I say, okay, over there is a pest. It's a trips, for example, and then the system kind of trains itself.
Actually, one of the things that you mentioned, and I think it's really important, and I love because you already explained it a few times to me. You said deep learning as a type of AI, but there are different types of AI. Could you explain like the different levels? Because I love your explanation of that.
Okay, I'll try to redo it then. um, but yeah, first, I don't know if anybody's listening who also has knowledge about artificial intelligence, because right now I'm going to give a very simplified explanation because you have a lot of definitions, a lot of interpretations, levels, and so on. But first of all, you can see AI as just a system which performs a task, and that task normally requires human intelligence. I know it's very broad, so you actually have three parts: a system, a task, and human intelligence. That's the three things you have in it. And then AI. is the broadest term, but that can, for example, be a deep learning model that I'm using, like a pest detection, but it can also be a vending machine. It's also AI if you look at it, because it performs a task. It decides, am I giving you that soda bottle, yes or no? If you put the correct amount of money inside of it, that's rule based, but that can also be seen in theory as AI, for example, then. But basically for AI, you have data which you put inside, you have rules that you put inside the system, and it outputs answers, solutions to it. For example, if you would, I think I explained it to you using a plant sorting machine. So you have a machine which needs to sort 3 types of plants. What you do, you kind of measure a lot of plants, get the features out of it, you phenotype them, you get the height, the weight, the shape, all those parameters you get out of it. And you look at it and you say, okay, if the shape is cylindrical, let's say, then it's a cactus. And you put it inside the system, and then the next time you feed data to it, so just features and rules, then the system will know, okay, I look at this feature, okay, if it's bigger than this or that, then okay, I can classify it in that class. That's generally speaking also AI. But then a subfield of it is machine learning. And machine learning is very good at pattern recognition, for example. But the difference here is that for machine learning, you still provide data, input data, but you don't provide the rules most commonly. Most of the time, you don't give the rules, but only the solutions. So you kind of say, you feed the input is data, the other input is solutions, and the system learns the rules. For example, for the plant sorting machine, you give it a big Excel table filled with all features, and then you add an additional column with the answer, so the class to which plant it belongs, to which plant category it belongs. And then the system will look at all those features, look for patterns inside, how it can classify and get to the answer that you also gave as an input. That's machine learning. And then deep learning is a subfield of machine learning. Yeah, you can say it's quite the same. It's also not giving, it learns the rules itself. You don't give it, but it uses more complex data. But as for machine learning, I kind of gave it tabular data, so an Excel sheet with all the features nicely put in columns. For deep learning, I just give it a very, very, very big data set, very big Excel table, like all kind of features. Some of them are useful, some of them are not. Like I can mention the daytime, also I don't know how many people that were walking around the field. That doesn't make sense to make your classification based on that, but that's something that the system also needs to learn. So it kind of looks at all those features and looks, okay, this, and this is useful, this not. It waits, so it trains itself, and then it gets to the outputs also. So it learns the rules itself. That uses neural networks, deep learning most of the time. So yeah, and they call it deep learning because it has like a neural network with very deep layers, so a lot of layers behind each other. That's why it's called deep learning. So AI is the broadest term. A subfield of it is machine learning, which is good at pattern recognition. Machine learning, for example, support vector machines, case nearest neighbors, and so on, are also machine learning. And then a subfield is deep learning, which is more like object detection, ChatGPT, large language models, image generation, and so on. That's then more deep learning.
Yeah.
I hope that was clear. Sorry, Jeroen.
No, no.
It's longer than the last time I explained
it. To me, it was clear. So AI in general is when you replace some human intelligence, let's say. Then you have machine learning where you don't actually say these are the rules and you just give it data. And deep learning is when there's a lot of layers in between. So it's similar to machine learning, but there's a lot of different layers in between.
Yeah, I think simplify, you can say it like that, yeah.
Yeah.
Because like the borders between all those subfields are like very vague. It also depends on
Yeah.
what you classify as what, but I think I would pass the exam if I would explain it like that.
Okay. And maybe also, because so you use deep learning, but
Uh-huh.
there are a lot of stories of biases based on deep learning. For example, there was an algorithm that was trained to recognize the difference between dogs and wolves and
Hmm.
worked perfectly. And they recognized that the machine learning or the deep learning was actually just seeing if there's snow, then it's a wolf. If there's no snow, there's a dog.
Yeah,
That's obviously not what you want. So
yeah, yeah, yeah.
how do you distinguish between that?
Yeah, it's deep learning is very powerful because it can find patterns which are too complex for us to see, for example. Right now we're focusing on image data, like you say, but you also have then other types of data like audio, genetic data, and so on. It's very good at finding patterns, and you need to be aware that if you feed your training set, so is it okay if we stick to images? I think that's
Yeah,
the
sure.
most easy type of data for people to understand. If you feed those images of dogs and wolves, for example, yeah, you need to make sure that there aren't any other differences. It's really only the thing that's on the image that changes, only the dog and only the wolf. Yeah, you could solve it by kind of cutting out the dog and the wolf,
Yeah.
and put it on another background that everything has the same background or just a random background, doesn't matter. That the system only learns to classify based on the the dog or the wolf features.
On the feature that you're actually interested in.
Yeah. Because yeah, it also when I'm taking my pictures for trips, for example, I also need to make sure that the lighting conditions are the same, are always the same. Because if one day I only photograph trip species A, and the next day I photograph best species B, but on day B, also the light intensity changed, then the system will just look, okay, if it's a light intensity, then it's this trips, and if it's low intensity, it's this trips. It's a lazy system. I mean, it's just optimized for energy efficiency and resource efficiency. So it just like looks at what's the easiest way to classify, and indeed, dogs and wolf, for example, that example. If you put snow on the background, or on all images, training images, you have snow on the background, and on the in one class and in the other class not, yeah, the system will just look at that. And that's actually a very um, uh, tricky part about deep learning. Like you think, oh, it's working nicely, and then you give it another training set, test set, and then you see, ah, shit, it's not working. Um, and that's a problem with deep learning then. It's a black box, they also call it, because it learns the rules itself. But what are the rules? That are just the weight actually of the neural network. And maybe I can quickly explain what a neural network is.
Yes, please.
Okay, I'll try to find a analogy with something you can imagine. So I'll try to explain it like this, and if it's not good, you can just cut it out. um, but for example, if you have a prehistoric civilization,
Mhm.
and they kind of live next to a forest where there are a lot of wolves or other bad animals living, and they kind of want to create a warning system. So there's just one guy, so the mayor of the city, say it like that, and he's sitting inside the city at his terrace of the big house where he's living in, and he just looks to the east, let's say, where the forest is. But that's, let's say, 50 kilometers further the forest is. So he really can't see if there's a wolf or not present. So because of that, he kind of every kilometer he puts a small hut with a guy inside, and the only thing they can do to communicate to each other is using smoke signals, and they kind of put them in a grid. So every kilometer you have one of those guys sitting next to each other, and I mean also an x and y axis they're sitting.
Yeah.
Yeah, okay.
Yeah. So both to the left and the right, and in the distance between you and the forest.
Yeah, indeed. And but not all of those people are very competent, let's say it like that. So of course, who's the most trustworthy? The guys that are sitting at the forest. So if they hear something, they can say, "Oh shit, I hear something. I'll just light my fire. I give a smoke signal." But then that smoke signal rises, okay, and then the next guy who's sitting quite closely, 1 or 2 kilometers further, he can see it and he can decide, okay, is that only like a smoke signal because he's making food, or is it really an alarming signal? And then if he's warned, he can say, okay, I also light my fire. He gives also a smoke signal, and it goes to the next one. And like this, it can travel to the mayor, and then in the end, he needs to decide on all, because I think, for example, he can see 20 smoke signals, and he needs to decide on all those 20 smoke signals, is there a wolf present, yes or no? So let's say that's the general explanation. But as I said, not all people are as trustworthy as possible. Some are like very strict or like very scared, and they immediately light their system. Some are like very lazy; they kind of get to sleep. So what he can do, he learns over time. So like the first time a wolf appears, okay, the wolf gets through and just attacks the city. 20 people die. Think, okay, this didn't work. I didn't look at the right signals. So the next day he's looking again and he sees, okay, this signal, and this signal. Okay, I can see it. And then a wolf appears. He knows, okay, I should look at these three signals to warn myself if there are wolf present or not. And this happens, let's say, over 3 months. And over those 3 months, he also gives more fuel to the huts that he thinks, okay, that's a good guy. I really need to see that smoke signal better because let's say he's 10 kilometers far. I really need to see that smoke signal better. I give him a stronger weight, let's say, a stronger, more fuel, like or something to put on the fire to like a very big signal. And that's actually what the system is doing. So this whole warning system, you can see it as a neural network which are also like a hut represents here an artificial neuron or a node, or yeah, they have different names for it. And it kind of gives a signal to the next node then. But the intensity of that signal is also weighted. And we can see or you can say that it's the strength of the smoke signal here. And then that whole warning system gets trained over time. So the weights of all the different huts, they change over time. So, and in the end, the mayor, he is the guy who needs to decide, is there a wolf present, yes or no? That's the output. So you have the input layer that's next to the forest. Then you have all layers in between, which need to be weighted. And then you have the output node, which is just the mayor.
I think this is the best explanation I ever heard of a neural network. It
Yeah.
really is. It really
Okay.
is.
Maybe I should write it down to explain it
You did
better next
prepare
time.
this, right?
Just in my head, I thought about a situation, but
For me, this is completely clear because I totally
yeah, okay.
understand now. Okay, so we have to check this, and then he sees those are better, so we give them more fuel. I could completely follow your description.
Okay, well, but to come back to what I said before, the explanation of neural networks. So the trained model is just a big matrix filled with weight. If you would look at the trained model and open it, you would just get a Excel sheet with 0.5, 0.3, 0.35, like millions of weights, which correspond to all those nodes. But if I'm looking at those weights, I'm thinking, yeah, okay, nice numbers, but I don't know anything about it. So that's a black box. We are too stupid, yeah, not stupid, but we don't have the intelligence to interpret
Yeah.
that system. But they are developing right now like semi black box systems, which it's like explainable AI. And there they can, for example, the system in the end kind of give some rule or give some notion about how it reasons. You could also, for example, uh, because the example you gave with the wolf and the dog,
Mhm.
yeah, in that example, they kind of because they saw it didn't work on the new set, so they think, is going wrong. What is it? And then they kind of for every pixel that they put inside the model, they looked at, okay, what does it predict for this pixel? And then in the end, they found out that the snow pixel, it's like 100% sure that it's a wolf. So you kind of back propagate and see what it is. But that's quite a lot of work, how it reasons to back propagate. But they're kind of developing like more reasonable systems right now. Also because yeah, people are getting more and more scared about black box systems, and that's also countermeasure.
Yeah, because I've talked about this in another episode about where they use actually hydrological models, so on a full continental scale. And there's also part of AI in there. And they're developing, like you said, actually those systems. For example, the water flow is combined by 5 equations, but you only know 3 of the 5. And AI just makes the connection, but they're now working on systems that actually make the connection and afterwards say, that's how I made the connection.
Yeah,
So you actually get mechanistic models out of your AI, which
yeah,
is
yeah,
insane. And you can
yeah,
get
true.
equations you would never thought of.
Yeah, true. I mean, I think I don't know which equation it was. It had something to do with astronomy. And I don't know. They kind of developed an AI system quite recently, and it's named to a mathematician, I think. I don't know the name anymore. But they kind of fed him all the data for which were needed by a scientist who did, I think, 60 or 100 years about thinking about an equation. It has something to do with astronomy, but I don't know the equation
Mhm.
anymore. And that AI system learned it in 3 hours. It also came with the same equation, and that's like what
Yeah.
60 to 100 years of human civilization, and you just fixed in 3 hours. The same with chess. I think it's Deep Blue, the the AI chess computer, which beat the world champion in I think 1997 or something like that. Um, but then they just kind of trained the system. But right now they rebuilt that system. And I mean, chess is like, okay, it's a game, but all the strategies, like if you go to a chess championship or a chess club, they kind of teach you certain strategies. And that's like given from generation to generation to generation. Um, so all those special strategies, yeah, we know it because it's also some part of human history right now. But they kind of, with reinforcement learning, it's called then, they kind of have a system which doesn't know anything about anything. It's just a stupid model. And then they let it play chess to another system. So it kind of plays chess to itself. And then they just say, yeah, you can't do that or you can't do this and so on. And I think also in 5 hours of training, of course, it simulated, I mean, millions and millions of games, but it got better than the best chess champion at this moment, which has like, yeah, human civilization and all the strategies from, yeah, I don't know how long they played. And that's insane, yeah. But once again, you can get very scared right now because you think, oh, okay, and in 5 hours it gets better than us. But that's only in chess. If you give it another simple task, like I don't know, classify if this is a computer mouse or if it's a keyboard, yeah, it can't do that because it's only trained for chess.
It's not something you originally said, but you mentioned it to me that AI is not going to steal your job. The person who's able to use AI is going to steal your job. And I think that really struck home because it's like you said, we should not be afraid of AI, although maybe there are some reasons to be cautious, of course. Caution is never a bad thing, I think.
Yeah,
Um, but at this point, it's more important to understand it than to be afraid of it.
yeah. But to be clear and to be honest, I'm not a computer scientist. I'm a biomedical engineer and environmental engineer, but I use AI. So I'm not the right person or the guy who you should listen to decide, oh, AI is good or bad. And I also can't say if it's good or bad. I just, people most of the time compare it to the invention of the internet. Um, because when the internet was invented, a lot of people were pro, a lot of people were con. But right now, you just can't imagine a world anymore without the internet. Look at all the benefits that internet brought. It's crazy. But coupled to it, you also have bad things like illegal weapon markets on the dark web. You also have child porn and so on. Really bad things also caused by the internet. But I think the benefits of the internet clearly outweigh the bad things, which doesn't mean that everything is good about the internet and we shouldn't control the bad things. Of course we should. But that's the same with AI. So when was the internet invented? 2000, something like that? Oh, yeah,
And
invented,
no,
like clearly
yeah,
outrolled.
yeah, outside it might be, but the early signs were a lot earlier.
Well, let's say, yeah, if you're, let's say 2000 as the year
Yeah, yeah,
2000 as the cutoff.
as a
But if,
benchmark, yeah.
yeah, as a benchmark, if you were living back then and you were like, let's say 40, and you say, well, that new technology, I'm not using that. I will never use internet. Well, I think you won't have the best 20 years of your life until now, or 24 years of your life, because yeah, the first years afterwards, people started using it and so on. And right now, you can't do anything anymore without the internet. And that's the same with AI, because, for example, if you use ChatGPT, um, I think ChatGPT everybody knows right now. Very nice, but you should use it wisely. You can't just be a student and let your master thesis be written by ChatGPT. your thesis will probably suck, but it will tell also bad things and things that aren't true and so on. But for example, I'm a PhD student at Ghent University, and there right now they changed their policy that you can use ChatGPT, but you should mention where you use it for, because they know that it's here, AI is here, it's good, it works. There are a lot of like bad things or like not bad things, like things that aren't working properly at this moment, but it kind of works. It's in most tasks better than us if it's really trained on that. So it's here to stay. And that's why they also changed their policy, because they couldn't stop it and they couldn't check if it's written by ChatGPT or not. But what this at this moment is good at for using ChatGPT, for example, and all those theses, not everybody was writing nicely. You have good scientists and they're just their writing skills aren't optimal. Are they bad scientists? No, of course not. I mean, their scientific research is the most important to me, but you need to write it on paper anyway. So they kind of write it in their writing style, very short sentences or very long sentences, let's say. And then they just put it into ChatGPT and say, let's rewrite this for me. And that's what they allow. They say, okay, you can just use it. And then what comes out is very, very nice. And that's like the collaboration between human and an AI system, because that's also the best. I also listened to a podcast. I heard it yesterday. Yeah, the Nerdland podcast.
Yeah.
Yeah, and in there they also mentioned that Kasparov, like the chess champion that was defeated by the AI system, right now again beat the AI system by
Oh, really?
competing, but by collaborating with another AI system. So it's like the human, it's collaboration. Yeah, it's collaborative intelligence, I think they call it.
Is it then also sort of reinforcement learning, but with a human? Did he learn from the system, or was it really he was working together with the system?
I don't know the exact details. They didn't mention it. It's like, yeah, I just know that they collaborated, but they explain it that an AI against an AI will always choose, let's say, the most optimal solution. But then if a human comes in, humans are also not stupid, have their gut feelings and so on. And that kind of can trick a whole AI system if it's not designed properly. If you do like a very stupid move, it can make the system fail because it thinks, what?
I think it's a very important point because you said like we can use AI and ChatGPT is here to stay, I assume. But we have to be careful as well because that was from when ChatGPT was quite new. There were lawyers, I think it was in New York. It was definitely in the US, but I think it was New York that used ChatGPT because they said like, okay, we have this case, we need some precedents. So they asked ChatGPT for precedents, and then it gave them several suggestions like this happened, this happened, this happened. And when they were in the court, turns out those things didn't happen. ChatGPT is a language model. It can make stuff up. It just makes that the sentences are correct.
It's also not designed actually to be used like that. It's actually designed as, yeah, like you say, a language model. It's just a statistical, like on your cell phone, you have like if you type a sentence, it predicts the next word.
Yeah. Word
But that's
suggestions,
actually,
stuff like
yeah,
that. Yeah.
that's actually ChatGPT works the same, but only it doesn't look only at the word just before, but at the 1,000 words before and the style and the things so on, very complex. But that's like a word prediction. So if it would be trained on a data set where like if I say I go walking with my dog then it will predict park, because that it has seen in all those training sets that dog and park are like coupled very clearly to each other.
It doesn't understand what it's doing. It just makes
No,
like
no,
what's
no.
the most possible or most logical next
Yeah,
step.
true, true.
Because there was
Be-
also stories that they fed all books of Harry Potter
yeah,
to a
yeah, yeah,
language
yeah.
model, and it predicted or it wrote the next book, but it also included uh, characters that already died because it can't interpret
No,
died.
no. Yeah, and it can't interpret anything. If I said like I'm going with my dog to the park, it doesn't know the concept dog. It doesn't know the concept park. It just, yeah, knows those words. It doesn't know anything more than that. So to say like to come back to your question, sorry, like
Yeah.
if you would lose your job, it's just those systems. I think humanity and also the we say it, the community doesn't expect everybody to become an AI researcher or expert. But like if, for example, ChatGPT exists and it can help you in your research in your daily life, it's better to use it. If it's more efficient, then use it. I'm not saying AI is always better. No, if you can, for example, in research, then like we do, if you can fit a linear model, yeah, it doesn't make any sense to train the deep learning model, train for days, use a lot of electricity to train it, and then come to the same conclusion. If a linear model is the most optimal, that's actually a linear model is actually a deep learning model with only one layer, because that's also the summation of the weight input signals. So it doesn't make sense then. So use it wisely. For example, if you're using, if you want to know who's the, yeah, if you want to ask anything to ChatGPT for stupid questions, let's say, who invented the cell phone, for example, or who invented the phone? If you feed it to Google, I think that uses around 1/30th to 1/40th of one cell phone charge. But if I ask it to ChatGPT, it kind of, yeah, it goes through the whole cycle of predicting the next word. Then you get a sentence like, okay, it was Bell, I think he was called, invented the phone. But then it uses, depending on how long the output is, 1/10 to one full charge of your cell phone. So it's like 30 to 15 to 25 or 30 times more electricity that it uses. And so use it wisely, because yeah, it doesn't make sense just for Googling. Like you can Google 40 times, 30 to 40 times.
For the same amount of energy.
Yeah. So, but I think it's here to stay, and it will only like, yeah, I think we will move to a collaborative system, collaborative AI system in the whole society, which is not bad. I think it can help us a lot. Like anyone who was mad about the invention of the GPS systems, yeah, I get them. But right now, everybody uses GPS, and all the major things that are like coupled to it. It's so nice that it was invented. So I think we should look like that at it. But yeah, you also mentioned we should be careful, and that's true. Like in Europe, they're very, very careful, and it's good that they're writing legislations right now, because they waited too much, to my feeling, or waited for too long. And right now, yeah, the problem is with AI that it's developing right now so fast that legislation is lagging behind. But then you have the, let's say, yeah, conservative Europe, but Europe is not that conservative. But like on AI field, they're like very, yeah,
You can say conservative.
yeah, conservative, or yeah. And then you have the USA, and then the USA, like everything with AI, basically you can do anything. There's also legislation coming, but they're like more like, if something bad happens, then we're going to invent the legislation for that, which is also an opinion. I'm not saying if it's better or not. Who am I to say that? But yeah, that way in Europe, a lot of innovation maybe is going slower in that case.
Yeah.
But on the other hand, yeah, maybe it's a, yeah, in Dutch is a voorzorgsprincipe. I don't know.
Yeah.
It's better to
Precaution,
be,
something like
yeah,
that.
yeah,
Yeah.
it's better to be cautious. But yeah, I'm not a believer of that AI will take over the world, that we will invent a system that kind of tries to, yeah, get over the world and take over the world. Because like I said, for example, the trips detection system that I'm developing, it's very good at one task, detecting trips. ChatGPT is very good at one task, predicting text and so on. And yeah, okay, they try to make a AI system which kind of knows the concept wolf, knows the concept dog, and so on, and kind of integrate everything. So it's a system that kind of, it's like a Siri on steroids, which can help you with anything, knows anything. But yeah, we're quite far from that, from there. And also because, like, if I shut down my computer, which is doing the model, and like I train the system to detect as many pests as possible. That's its goal. Detect as many pests as possible, for example. The moment I shut down my computer, the system isn't mad because it can't work anymore. It's not like trying to find a way that I can't boot or shut it off anymore. That's not how it works. But the problem here again is the system itself isn't bad, but it's the human applications and the things we do with it. Same with the internet, like I said. Yeah, you have the dark web. Yeah, that's because we did bad things with the internet. If you use it for military, for example, military applications, yeah, I'm a peaceful guy. But yeah, if your enemy is using it, yeah, you should also use it. But then it's like kind of Same with the atomic bombs at the moment, and nuclear
The Cold
bombs.
War.
Yeah. So I think, yeah, you should have legislations about that. Like, Russia and USA and other countries have kind of a system which continuously monitors if there aren't coming any nuclear rockets to your country, because
Yeah.
it's like the first responder of I don't know, first strike and second strike and so on. So the moment you see it coming, you should also fire your rockets. Otherwise, you won't have
It's
the
too
mutual
late. Yeah.
destruction. Yeah. But right now, this is done by humans. They continuously check radars and then they think, okay, is it useful or not? Should we do it? Yes or no? And then in the Cold War, you really had very, yeah, close calls. Like that there was some noise, and they thought that America shot a nuclear rocket, and then Russia really wanted or the USSR wanted to send their rockets, but then I think they were with three, and only one guy said no, the other two said yes, and then in the end they waited, and it wasn't. It was just a bird, or I don't know what it was. But then it was good that they didn't fire it. But if you give that decision to an AI system, which is way better than humans, like an AI won't sleep, won't fall asleep, and so on. But yeah, if it's a deep learning system, and you say that it optimizes or you ask the system optimize that there won't be coming any rockets here. Okay, the system will train and check radars and so on. But then if inside the system, in the deep learning model, it kind of switches, okay, the most optimal way to avoid that there are coming rockets to us is firing our rockets. And that's what you don't want to happen.
Like you said, it's often an optimization, and we have optimizations, but we have like our rules. How would you call it? Our
Ethical,
um,
yeah.
yeah, our
Society and
ethics. Like
ethical
you say,
rules.
okay, that's something we do or we don't do. But the computer or the AI doesn't have those ethical
No,
rules.
it doesn't have
And
any notion about society. Yeah.
no, because that's also actually what a lot of social media does. The optimization is keep people's eyeballs at my social media.
Mm-hmm.
And like there has been multiple reports that AI actually found out that people will stick longer to social media when they're angry. So they're
Yeah.
actually
Yeah. Yeah.
stimulated to be angry, which
Mm-hmm.
is also maybe not the goal of social media, getting people angry.
Why do you think that Facebook went from just the like button to 6 buttons or more, like the heart and the angry button and so on? So it's
Yeah, yeah.
also, yeah, you're helping it.
Yeah, no, that's true. But yeah, it's just an optimization. And sometimes you get optimizations that are very deliberate, but sometimes, like you said, in the AI system, it's an optimization that we just don't think about because we don't conceive it as a possibility. There's just we'll fire our nukes and everything is solved. That's not something we think about. But that's also a limitation that the AI doesn't have.
Yeah, true. And that's why you should, I think the future is in collaborative systems. Like if you ask, for example, now to DALI or Stable Diffusion to generate an image, yeah, not every image that it generates is fine. Sometimes you need to tweak it a little bit, ask 3 to 4 times to generate it. Um, so yeah, you still have that human interaction that is needed. The same with they have a song festival contest for AI songs and so on. Like the pure AI songs are quite bad, or they used to be quite bad. But you always have that human tweaking, like, okay, this is what we think is nice and so on. So I think the future is in that. But of course, yeah, we should be cautious, but I think the governments are cautious and so on. And also, like, there was a letter from, I think, Musk and a lot of other top AI guys who kind of wrote a letter in which they asked, okay, can we just have a general treaty or act in which we all promise to stop AI development for a moment because we don't know where it's going to? Because right now they don't have the rules because it's going so fast. And if if there are 10 companies and all of them say, okay, ethically it's not fine if we would do this, but then suddenly one of them does it, yeah, the other ones need to follow. So that's why they ask with that act, like, please, can we put a break on the development for a moment until we know what's for sure, what will be the consequences of it, or what is good and what is bad.
But I think, and think like you said, like DALI or other image creation AI, you also have the highly, how do you say, creative part of it. And that's very subjective. Like art is very subjective, and what is nice is very hard to capture for an AI, I think. Because
Yeah, true.
yeah, even for people, you might have an image that 10 people like and 10 people don't, but it's so subjective, and I think that's hard to capture by AI, stuff like that.
Yeah, true. Let's say if you want to generate an image of me, for example, in the style of Van Gogh, Vincent van Gogh, for example. And if as long as you feed it enough images, it will generate something that looks like it. And okay, the models will become better and so on. Like in the beginning, like it's very bad at making fingers and so on. You always have 6 fingers or 7 fingers or something
To
weird
be
is
honest, a
happening.
lot of painters are bad at that as well. So
Yeah, true. Yeah. But then, yeah, it will generate something, but it doesn't have emotion, that system. We want emotion to something, to a painting. And like it's sometimes, I don't know, a small imperfection or whatever that triggers the emotional thing. And that AI is developed based on a lot of images and it tries to mimic it. But yeah, it's yeah, I don't know anything about art to be honest, but yeah, it doesn't have emotion, so it's not. I think we should decouple to it. It's like, yeah, your car is also designed to get you from point A to point B, and it's very good at doing that. But the car also doesn't have any other thing. It doesn't live. It's as long
yeah.
or as far as I know, it doesn't live.
As far as I know as well. I mean,
Yeah. So yeah, true. You have that emotional, that subjective thing, and yeah, maybe objectively the AI image would be better, but subjectively we prefer the human thing. It's yeah,
well, actually, when you go back to the cars, you mean you have so many different cars, and in essence, we just want to go from point A to B as economically as possible, but still sometimes I prefer it a little less economical, but it's nicer. But what is nicer? Yeah,
yeah, true. And if you don't put it into the data set on which the system is trained, it won't take that into account.
yeah, it will just be as fast as possible.
Yeah, that's true. Just bind yourself onto a rocket and fly you to point
Yeah,
B.
it will be faster if you bind yourself to a rocket, go to space first, and then come back to Earth on
Yeah, it's like
Uh,
uh, the latest ship of Elon Musk. I forget the name now.
that's not
The
the
space
Falcon, right? Or
Starship.
the
Uh,
Starship, yeah.
they also want to use it actually for intercontinental traveling once it's working, because then you would go from, yeah, I don't know anymore, but like in 12 minutes you would be on the other side of the world. I don't know the from point A and point B anymore, but it's actually just goes to space, then flies around and then comes back again.
That's insane, right?
Yeah, true. I don't know the CO2 equivalents that come to it, but yeah.
Well, we're actually getting to the end of the episode, but before we close, do you have a take-home message for our listeners?
Yeah, I would say don't be afraid of artificial intelligence. I mean, the term is very broad. Everybody uses a vending machine, so everybody uses AIs from time to time. If you just take that very broad definition, but yeah, use it wisely. If it can help you, just use it because it's like the new internet. To have a lot of good applications, but also be skeptic. For example, for ChatGPT, what gives it as output? Yeah, just always check if it's right, yes or no, and also with all the other applications. Because I think with all the fake news and so on, like with the deep fakes and so on, yeah, that's a bad application of AI and can get like yeah, on country or nation levels, bad consequences. If you give the example of social media, and I'm not focusing on any platform right now, um, yeah, you can kind of steer the elections inside a country that way. So I think it doesn't make sense to say we won't use AI because there are risks. Yeah, there are risks coupled to everything, and I think I'm really yeah convinced that the benefits are way bigger than like only like for example only in the biomedical applications. It's crazy. Also in agriculture, in any field, it's crazy what it can do. But yeah, you can always use it for bad things as well. And I think there we should be cautious and have you can also have AI systems which track other AI systems or for example, at the university, first they had a system which kind of detected ChatGPT. I don't know how exactly they did it, but because ChatGPT always kind of generates something else if you ask the same query. But yeah, they made a new system. Then ChatGPT updated. They had to update their system, and then in the end, they said, "Okay, we won't do it anymore. It's allowed, but you should use it wisely. Be skeptic." And yeah, it doesn't make sense if it would help you and save you time. Yeah, just use it. Doesn't make sense not to use it. But be aware of all the free AI systems, like for ChatGPT and so on. Just know everything you put into the system in the free version, not the paid version. Yeah, you give your data to them. So if it's a personal thing, they also list it there. Yeah, if it's very personal, don't put it into the system, because it's yeah, and also they can't get it out of it. Like OpenAI, for example, for ChatGPT, they won't get your password or whatever, or yeah, it's like a big amount of data. They won't clearly get it out. But for example, if I put my password for my email account in it, yeah, there is a chance, a very small chance, but if I type into the system, okay, my email address is this, what would be the perfect password? Then it generates a password that's true because it has learned, it has linked that email address to that password. I mean, the chances are very small, and like they are continuously building in like nice behavior things, like for example, DALI and so on can't generate nude images. But yeah, they kind of introduce rules, but then people are clever and they kind of get past the rules. So yeah, just be skeptic, be analytical, and but yeah, don't be afraid of using it. It's good. It's here to stay, and it will stay. AI. I'm very sure of that. If you're interested in AI, yeah, just take classes. You have a lot of free courses online. If you want to have a very deep course, I think from Andrew Ng, it's called. It's a
Ah, yeah, yeah.
very extensive course. It's also for free.
It's on
I also,
Coursera, I think.
yeah, true. I also listened to a podcast, Machine Learning Guide, I think by Tyler Renelli or something like that. I also learned a lot of it. He's also he learned it by himself, and I think that's very nice because you start from the same background knowledge, and then he starts building. Um, so yeah, sorry, very long answer again. Yeah, don't be too afraid of it. Be cautious, but I think AI will help the world in a very good way. Um, but yeah, be cautious and use it wisely.
Yeah. And I think it's a very good point, actually, that you just said to be cautious about what you put into the system as well. Because there have been documentations that some company information was leaked because they used ChatGPT to help them, but then a competing company asked similar questions and got the answers from the other company.
Yeah, true. Yeah, let's just use it for nice stuff and don't troll other people and just earn your money in a in a right way. So yeah.
I think that's a great take-home message. The longest take-home message we had, but I
Ah,
think it's
sorry.
great.
Yeah.
No, no,
Oh.
no, that's perfect. That's perfect. But we're going to round up here.
Yeah.
This was
Okay.
Apple Finch Pudding. I want to thank Broes Laekeman for the information, and let's meet again for the next episode of Apple Finch Pudding.